Okay, so after that initial finding, which was that the larger rhombic tricontahedra could be made of this stellate and three phi-scale down rhombic tricontahedra, I decided to investigate the actual E modules themselves and find out what's going on with them. So, for starters, we're just going to isolate the this will be the origin of the whole form right here, and then this is one of the fat rhombic hexahedra from quasi-crystal fame, and the 20 of those make that stellation. And I'm also showing the E modules that are then filling in those voids. Then the outer surface is, this is a cluster of 6 E modules. There would be 20 of these forms to make the rhombic tricontahedron. So from these 4 points here, these 3 projecting down to the fourth, the origin, that is your overall E module. So there's a suggestion right away that, well, I have the next smaller size E module laying in that valley, actually 3 of them per E module, because I have a cluster of 6 here. And so what is going on here? It looks as though the overall E module can be made of smaller phi-scaled E modules, at least 3 of them. And that would be, the 3 of them would be this part I'm trying to isolate right now. Oops, can't seem to do it right now. Maybe it's too small. Maybe I gotta make this a little bigger. Okay, so I'm trying to show this section of 3. There's one, whoops, there's one here, one back there, and one here, because you see how the rhombus is divided into 2, and then there's one here. That's the one that fills in the valley. That is the beginning of trying to figure out how, see that you can see the overall E module there, 1/6 of the whole thing. You can see that, well, but now what the real question is what is inside of that fat rhombic hexahedron? Okay, so now here's a skeletal model of the fat rhombic hexahedron that 20 of them make that stellated shape. As you can see, more than likely, that I have made it up of even smaller E modules, because remember that folding property on this rhombic half rhombus here? That can be folded, this point folding over to this point would give you a rhombic tricontahedron of that side. I'll demonstrate that real quickly if I can by just the faces, and then what you do is you say this is my center, and then you say I just want to see these 3 faces, and you put icosahedral symmetry, and that is a rhombic tricontahedron. So then that's like 2 sizes down from the original E module that projected from the center to that larger rhombic tricontahedron. Okay, so we have a total of, there's 6 rhombic faces, and each face is made up of 4 E modules. Okay, they're at different scalings, but it's not that easily resolved, and that there's actually 6 of these tetrahedra that I've shaded clustered together, and I actually called it the unresolvable tet. It can be made up of E modules, but it's an infinite progression. It's very interesting, and I hope to cover that next. Okay, now I have 1/6 of that rhombic hexahedron, the fat rhombic hexahedron, 1/6 of it, because as you can see, this bottom, let's call this the origin right here, and then these 3 points project out. That makes the initial E module form, and of course it's going to radiate in all directions that same way. So now we have that, but we know that it has to be larger, of course. So then we can build out our remaining three. Remember those three from the tricontahedron that fit in those valleys? That's what we're putting those three in now. Then we have one more over here that we have to do. And I think I can get this right. No, too long. Here. Oh, no, too long. Okay, and now we have a E module. If I ever say T module, it's interchangeable with E module as far as the form goes. It's more of a precision in the mathematics of volume. But here we have 4 of the E modules plus that unresolvable. No, you know what? I gotta take that back. I called that a remainder tet. Unresolvable is something else. I'm so sorry. It's a remainder tet. That's what's in there. And then there's the 3 other E modules here that were that filled in that valley, because this is part of that valley on that stellation right here, this face here, and that's what those 3 fit in. That was what. Okay, that's the depression. These fit in the depression, and this crosses the valley, this piece right here. And that was how those 3 E modules fit in. They're the next larger size. So we have 3 different sizes. We have an E module this size, then we have one this length here, and then we have the overall one. So those are our 3 sizes of E modules, which tells us that we should be scaling our modules by phi to be able to make this form.